Today we're going to talk about assessing normality. So before you watch this video, you need to know what a normal curve is and how to use it, and know how to use z-scores and standard normal calculations. So we have recently been using the mean and the standard deviation of a data set to fit it to a normal curve and estimate population percentages, right? So now we're going to move on just a little bit to being able to recognize that there are some data sets out there for which such a procedure is inappropriate. In other words, we can't use a normal curve for some data, and we need to know when. So we're going to start with Dominic, who decided to research word lengths in his favorite novel for his statistics class. He used a sampling technique, and coming up soon we're going to talk about sampling techniques, to select 40 words from the book. Then he created a table of the sample words and the number of letters in each word. Then he used all of that information to create a histogram. So we're going to look at the table and histogram that Dominic created to solve the problems or to answer the questions that follow. So here's his table. You can see all of the 40 sample words that he chose, and he counted the number of letters in each word. And here's the histogram of how many words had each length, right? So he had 8 2-letter words, he had 8 3-letter words, but he only had 2 5-letter words, and so on and so forth. What do you think? Does this look like a normal curve? Let's look further. So we're going to answer the following 5 questions. These are actually in your workbook if you want to follow along. First of all, we want to find what percent of words in the sample have more than 10 letters. More than 10, remember, does not include 10, so I'm just looking at that 11 and 12 letter words. He only had 1 of each, so there are 2 words total that had more than 10 letters. Okay? When I change that into a percent, 2 out of 40 is 5% of the words in the sample. Now we want to estimate the number of 3-letter words used in the entire book, right? So when we estimate, we can actually use our sample set to estimate the number of words in the whole book. So when I look at the number of 3-letter words in my sample set, okay, and assuming that the sample set is representative of all the words in the book, I can then use the percent of 3-letter words to estimate the percent of 3-letter words in the whole book. So when I look at that, I find that 20% of the words in the book are, 20% of the words in his sample are 3-letter words, right? 8 out of all 40. So I'm going to assume that 20% of the words in the whole book are 3-letter words. That's kind of a big percent for just 3-letter words, right? But remember, there are English words like the and was and why and how, and those are really common in the English language, so it kind of makes sense that there would be more 3-letter words than a lot of others. Let's say we want to find the mean and median word length for the sample. So I can go back to the chart, I can enter all those values into my calculator, or I can just add them up and divide by 40, right? All of that kind of stuff works, but we're going to find the mean and the median. I think I need to go back to that. So the mean is, remember, the sum divided by the number of data points. When I do that, I find that the mean of this data set is 4.65 letters per word. And the median, of course, we've got to put them in order and find the very middle, and we find that that's 4. Okay, so the median is 4, the mean is 4.65. That's kind of some important data for us. Next, we're going to find the standard deviation of the word length. So in our graphing calculator, we're going to put all the word lengths. And we find that the standard deviation is 2.7 letters. Question 5 asked, are the word lengths in the book symmetric? Right? Symmetric is what a normal curve is. So looking at Dominic's histogram, are his word lengths symmetric? No, not really, right? The word lengths aren't symmetric because the percentage of words that are above the mean, remember the mean was 4.65, so the percentage of words that have, that are longer than the mean is different from the percentage of data that is below the mean. So we have more or less, right? It's not even on both sides. So in this sample, I find that 62.5% of the word lengths are below the mean, are below 4.65 letters. And only 37.5 of the words have more than 4.65 letters. If this was going to be symmetric and normally distributed, we'd want to see more of a 50-50 split. It doesn't have to be exactly 50-50, but it needs to be really close. So there's a lot of different ways to assess normality, and when we say assess normality, we mean to decide whether the data is normally distributed. So we can use the empirical rule. I can check to see if approximately 68% of the data is within 1 standard deviation and 95% of the data is within 2 standard deviations, and so on. I can visually inspect the histograms for symmetry, clustering, and outliers. We'll talk more about that in a second. And we can use probability plots. So first, let's take a look at just the outliers. Remember that an outlier won't change a median, right? The middle number is still going to be the middle number, but it will change a mean and a standard deviation. Remember we talked about in normal distribution, the mean and the median are the same, or at least have to be super extremely close to each other. So an outlier is going to affect our normality. So if the mean and median are the same, or like I said, very, very close to each other, there's a good possibility that the data is going to fit in a normal distribution. So going back to Dominic's word length data, the mean was 4.65 letters and the median was 4. They're pretty close together. You could start to think that the data is normal. But then the fact that over 60% of the data was below the mean and almost 40% of the data was above the mean, that makes a symmetric distribution totally impossible, right? Besides the fact I can look at the histogram and it's pretty plain to see it's not normally distributed. One thing that's important in normality or normal distribution is having an appropriate sample size. If I only have a few pieces of data, it's not going to be very accurate. Remember, Dominic only picked 40 words out of an entire novel. That's not a very good sample size. Having a large sample is better. Most of the time we say at least 30, but if you're talking something really big like the words in a novel or the number of high school students in our school, you probably want a sample size much bigger than 30. A histogram is probably the best visual way to tell if the data is normally distributed. Here's a histogram that looks really close to normal distribution, and obviously this one's not. Normal distribution, this one's close enough. And definitely not normally distributed. You can tell by using the histogram if your data is approximately symmetric, right? Remember, it has to have a high concentration of values near the mean and be approximately symmetric on both sides. A histogram can also tell you about outliers. So here's something important with our outliers in a histogram. I have some outliers in this histogram that are off to the left-hand side. That makes a little tail on the left-hand side of my histogram. That left-hand tail makes this histogram skewed to the left. Or I can say that it's negatively skewed, okay? And in a negatively skewed distribution, the mean is really often less than the median, right? That outlier to the left is going to pull down my average. That's one way you can tell if you have negatively skewed data. And going the other way, if I have outliers that are off to the right of my histogram, I say that this histogram is skewed to the right or positively skewed. And in a positively skewed, right, or skewed to the right distribution, the mean is quite often greater than the median, since that outlier is going to pull that mean to the right. Histograms, to be kind of appropriate to decide whether it's normal or not, need to contain somewhere between 5 and 20 categories of data. If you only have 2 or 3 bars, you're not really going to be able to tell if it's normally distributed. Let's go through a quick example and then we'll end for today. In order to constantly improve instruction, we have a teacher, Mr. Hoople, who keeps careful records on how his students perform on exams. The histogram on the next slide displays the grades of 40 students on a recent United States history test. The table next to it summarizes some of the data, and we're going to use those properties of a normal distribution to determine if a normal distribution is an appropriate model for grades on the test. So here we've got a histogram of all the grades, and we have N, which is 40. That means there's 40 students in this histogram. We have mu of 80.5, or average. Our median is 85. We have a standard deviation of 18.1. A minimum score of 0 and a maximum score of 98. So a couple of different things you can do. First of all, we can look at the histogram and see that it's not symmetric, otherwise known as asymmetric. There's a skew to the left, right? The mean is also 4.5 points less than the median. If you look back at the histogram too, you can see that most of the data, or it looks like most of the data, is going to be higher than the mean of 80.5. It looks like there are way more students to the right of 80 than there are to the left. That's going to be a good indicator that this cannot be normal distribution. Knowing that there's an outlier on the test, right? Now there might be outside factors as to why that student got a 0, but still it's an outlier. If I could throw out that 0 on the test, my data would be much more accurate. Because of the outlier though, we have to say that normal distribution is not appropriate for this model. We're going to continue this discussion a little bit in class, but I think that's enough for today. I wish you a very good day, and I'll see you next time.